week, I think one day when a lot of you were prom decorating, basically, I kind of worked on this section. It was this one. I guess it's page 559. But I didn't really like this section. And I talked about it in class, but then I told you that we weren't going to do the homework in that section. So on this whole section, day 67 homework, I guess it's page 559 through 574. Is it that many pages? No. Maybe, yeah. 569, that's what it is. 569 is the page it starts on. Through page 574. Like I said, we worked on some of that stuff, but I mainly just kind of did a review that day. So if you want to go back and watch that video, that's cool. It's just really, it was more in-person stuff to help with the stuff that I had taught virtually because I had that workshop. So today we're going to start on this section. Which, finding values of trig ratios. There we go. Does anybody have any homework questions? I guess I should ask that at the very beginning. Yes, sir. Jose?
On the true response for day 65, letter A.
Okay, what page is it?
558.
This one, right?
Yeah.
Okay. A, right? Okay. So that's on page 558. It was that free response practice number 37. Okay, it says, during a hike, Jeff and John start at their campsite in the picture to the right, and then head in a direction that is 30 degrees west of south to a waterfall located at point B, which is a 6-mile hike. They then hike to an old Indian burial ground located at point C before returning to their campsite, which is 8 miles from the burial ground. All right, so what we need is actually labeled already in the picture. Using that given information, how many square miles did Jeff and John hike that day? Show your work. Square miles should make us think area. Because anytime you take a unit and you square it, that's the area of something. So we had a formula that we learned to find the area. Of course, you know 1/2 base times height. Unfortunately, we don't know the height of this triangle. Height is always at a right angle to the base, and this triangle we don't know, but it doesn't show a right angle for sure. So what we use is that area formula that we learned in this section. Looks like I didn't write on this one, but it was the 2 consecutive sides and then times the angle that was in between them. So this side and this side, any 2 sides are consecutive on a triangle. And then the angle in between those is this one. So it would just be those 2 sides times the sine of the angle in between. And then that you could just plug into your calculator, work it out. Is that cool? Any other questions on homework thus far? I didn't fill in that answer, but you have the sheet that has all the answers on it. Sure. Yes, ma'am. Yeah. What do you? Oh, yeah.
I don't know. I think I'm allergic to something.
Oh, okay. Yeah, yeah. All right. Then let us jump ahead then. Finding values of trig ratios. And this will help review a little bit too, hopefully. For each of the angles described below, and that symbol means theta, draw the angle in standard position. So let's do that first. We have angle negative 473 degrees. So if it's in standard position, that means its first side is here on the positive x-axis. If it's negative, then it rotates clockwise, the same way a clock goes. So negative goes clockwise, positive goes counterclockwise. And then, in case you've forgotten or just didn't know, we have 0 degrees. If we're going negative, each axis is another negative degree. So down here is negative 90, because you can tell that's a right angle. And then 90 more, so this one's negative 180. And then they just keep adding 90. So this one's negative 270. All I'm doing is adding 90 each time. So 360, negative. Then negative 450, and this one's negative 540. So I can see that my angle is going to be in quadrant 3. They go quadrant 1, 2, 3, 4. So it's going to land between negative 450 and negative 540. So I know it goes around once. So it's 360. And then it goes to negative 473, which is a little bit past negative 450. So that angle looks like that. So standard position means this lies on the x-axis, positive x-axis. It's going negative, so it rotates this way. And notice I've gone around more than once. That's why it has this little circle here. And then it goes around just a little bit more. Any questions on how we drew? That's negative 473. That's theta. Then, find the measure of the reference angle. The reference angle is always the acute angle that goes from the terminal side, which, where it ends, that's the terminal side, that orange side, to the x-axis. So there's a reference triangle. The reference angle, I'm going to call it theta prime. So to find the reference angle, which we'll call them theta prime, it might be helpful to first find this little angle. How much is that little angle? Negative 23, because I know that this is negative 450, and it's 23 degrees past that. So that's negative 23, or you can just call it 23. I mean, we're just worrying about the positive angle right now. Reference angle is a positive angle that always goes from the terminal side to the x-axis. So theta prime then would be 90 minus 23. So theta prime should be 67 degrees. And it's always going to be positive. All right. and then a positive coterminal angle and a negative coterminal angle. Coterminal means they land in the exact same spot on this orange side, and they're also going to have the exact same reference angle, but it can rotate to the right or to the left. If it's in degrees, all you got to do is add and subtract 360 until you get a positive number or a negative number. So, for example, it's negative 473. If I add 360 to that, I get negative 113 degrees. That is a negative coterminal angle. Thank you. Then if I take negative 113 degrees and I keep adding 360, because all I'm doing is adding a circle. I'm just rotating around again. If I add 360, I do believe, make sure I did that right. Yep, I get positive 247. So there's a positive coterminal angle. If it would have given me another negative, I would have added 360 again. So I add or subtract 360 until I get a positive or a negative, whatever it is I'm looking for. And 360 because that just completes the circle. It's going to obviously land in the same spot. All right, cool. So the next one is in radians. So let's draw it out. The first step is to draw the picture. So it's put in standard form. So if we're putting it in standard form, it starts at 0 radians. And this one's positive, so it's going to go counterclockwise. This one up here is 90 degrees, which is pi over 2. It probably wouldn't hurt, to memorize these. And I add pi over 2 each time, which is 90 degrees. So if I add pi over 2 and pi over 2, it's 2 pi over 2, which is just pi, because 2's cancel. Then 3 pi over 2. Then 4 pi over 2, which is just 2 pi. Now, I might want to change this to degrees. It might help me, actually. If I change this into degrees, I was going to try to do it without, but I'm afraid I'll get too lost. And the pi's cancel. You multiply by 180 over pi. 7 does not go into 180 evenly. I do not believe. No. So it would be 13 times 180